before we get started on this worksheet, I just want to go over a couple of the rules and similarities, symmetries that you see with quadratics, which will really help you. So you can just put your pencils down and watch this. So let's say that I have a quadratic and I know that the roots are x equals 5 and negative 1. Okay? So 1, 2, 3, 4, 5 and negative 1. Okay? And what if I said it had a max at y equals 4? Is that enough information to draw the rest of the quadratic? It actually is. So I'm going to draw a line at the maximum, 1, 2, 3, 4, right here. If that is a maximum, does this quadratic open up or does it open down, Miles? He's recovering. Oh, wow. I'm impressed. So it's going to be one of these parabolas. Do I know where it hits that red line? Halfway between the two roots. So if the roots are 1, 2, 3, 4, 5, 6 units apart, then the maximum has to occur halfway between those. So it's going to be right here. Does that make sense to everybody? Okay. If I told you this was the root and that was the maximum, could you find the other root? Ashton? If you knew one root and the max, could you figure out the other root? Well, we could count over 1, 2, 3 until I get to that line. And then you'd have to count over 3 more to get to the root. Make sense? So if we went through the intervals, what would the domain be? All real numbers. What would the range be? Close. It's negative infinity to 4. Right? The lowest y value is negative infinity up to 4. Do we include 4? Does it actually hit y equals 4? Yes. Then we could do increasing, decreasing, positive, and negative. And remember, all of the intervals are x's except the range. The range is the only one that's not an x. So for increasing and decreasing, I would divide the parabola in half. The right side is going down, and the left side is going up. So increasing is on the left. What is the interval of increasing? What's the smallest x for this piece here? Negative infinity until? Well, are we looking at x's or are we looking at y's? X's. So the x value for the switch is at 2. Where is it decreasing? From 2 to infinity. Right? Everywhere from here over, it's going down, and everything from here to there is going up. Okay? Now, do you notice a pattern between these two? The x's and y's switched, and one other thing changed. The sign on the infinity also changed. So if I told you the graph is decreasing from negative infinity to 1, where is it increasing? From 1 to infinity. So if you know one, you automatically know the other. Okay? And what is the significance of that number? Where does that number, what part of the parabola does that tell you? So the 2, x equals 2 on this graph. What happens at x equals 2? No. X equals 2. What happens right here? The graph doesn't, well, what do you mean intersection? That's where the maximum is, or the minimum. It's where it switches from up to down or down to up. Okay? So, if we look at positive, this graph has one positive piece. Where does it start being positive and where does it stop being positive? From -1 until 5. Okay? This graph has two negative pieces. One on the left and one on the right. Okay? So, the one on the left, what is the smallest x? So, because it has two pieces, we're going to do a union. And on the left side, we have -infinity. What's the biggest x on the left side? -1. What's the smallest x on the left side? 5 until infinity. Now, do you see any sort of pattern between these values? So, if you look at the union, the two middle numbers are going to be on the other positive or negative. Okay? Where else do you see those two numbers? Dylan? Not paying attention, I know. So where else do you see -1, -5? They're the roots. So if you know the roots, and you know whether it's up or down, then you could tell where the positive and the negatives are going to be. For instance, if I said that it was positive from -infinity to 1 and from 2 to infinity, does this graph open up or down? Why up? Well, let's think about it. Here's a root, and here's a root, right? So my zeros are x equals 1 and 2. So it has two positive pieces. So would that mean opening up or down? Well, let's look. If we open up or if we open down, which one of those has two positive pieces? The one going up has two. So where would it be negative? We can get rid of that one. Where would it be negative? Well, it's going to be negative from there to there. 1 to 2 would be negative. Okay? All right, let's actually answer one that's on your assignment. So I know that the domain is all real numbers. I know it's decreasing from -infinity to 1. It's positive from -infinity to -1, and from 3 to infinity. The max or the min value is -4, and I know the y-intercept. Okay? So just from this information, what can you tell me about the graph? The roots are -1 and 3. So -1 and 3. Good? What else can you tell me about the graph? The y-intercept is -3. Okay? What else can you tell me? Is it a min or is it a max? How do you know? The y-intercept is already below, between those two roots, so it would have to be a minimum right here. That's as low as it goes. So I'm going to circle minimum. Okay. What else? Does this open up or down? Up. Do we know where the lowest point happens? So it goes as low as -4, but do we know where it touches that line? How would you figure that out? So halfway between the roots, 1, 2, 3, 4. So I'm going to draw a line halfway between. Is that what you meant by intersection, Jerry? Okay, I understand you now. So the graph looks like this. Does everybody get that? Now once you have it graphed, you can answer everything else. What's the range? So this has a minimum number. So the lowest y value is -4. Do we include -4? Yes. What is the highest value? Infinity. Okay. Do I know where it's increasing? Where is it going up? From here to here. What is it? Nope, this is an x value, not a y value. 1 to infinity. Now, could I have filled that out before I graphed it? How? I knew the decreasing. So you just switch the x and y and change the sign of the negative. Okay? Do I know where the graph is negative? Well, it's between the two roots. So from -1 to 3, it's negative. Then the only thing left is the end behavior. As x approaches -infinity, so as x goes to the left, which direction is the graph traveling? So as we travel to the left, does the graph go up or does the graph go down? Up. As we travel to the right, does the graph go up or down? Up. So both of those are infinity. Okay? I'll put the answers up on the board. And then you should have everything you need to know in order to finish this out.